Hello, Mr. Simpson here with our video for 11.2 electrolytes. Please pause the video as always and take a moment to write down your learning objectives. Before we get into discussing electrolytes in particular, a couple things to cover about just the dissolution process in general. Okay, so solutions are homogeneous mixtures. If you remember way back to the beginning when we talked about mixtures as a type of matter, homogeneous mixtures are solutions. They consist of a solute and solvent. Solute is the thing that is dissolved, whereas solvent is doing the dissolving. And the universal solvent, you may recall, is water, the universal solvent. Okay, with regards to solubility, there's an important phrase here to keep in mind. We'll have lots of questions along these lines, but like dissolves like. So whether we're talking about the types of IMFs present in the molecular forces present in two substances, and are they likely soluble in one another? So when we talk about solubility, we talk about a solute being soluble in the solvent. Okay, so it isn't universal. Different solvents have different effects on the solubility of different solutes. So you have to reference both aspects of the solution. Okay, so whether it's due to solubility, the effective solubility is tied to similar types of intermolecular forces, or also the notion of polarity. Okay, so polar solvents will dissolve polar solutes and many ionic solutes because we're talking about the charge there, positives and negatives, that you would get the partial values in a polar solute and actual plus and minus in ionic solutes. And then nonpolar solvents would would dissolve nonpolar solutes. So quite common to get questions along these lines. Which of the following would dissolve in this solvent? And you identify the type of solvent and then look for similar intermolecular forces or polarity. So this is the first important step in our discussion here with regards to the solubility in the dissolution process. Okay, let's get into some electrolytes. So when something dissolves in water and produces ions, then what we have is an electrolyte. So you can see here that an example. So ethanol, which is a molecule of covalently bonded carbon, hydrogens, and oxygens, when it dissolves in water, you're not going to get, or mixes in water, you're not going to get ions. You're not going to get separated positives and negatives. So that is a non-electrolyte. So you can see here there's no electric current. An ionic compound, on the other hand, that would dissociate into positive and negative ions would conduct electricity. This is known as an electrolyte. We also have weak electrolytes. So an example here is a weak acid. So this weak acid is going to produce some H plus ion, but it's not going to completely disassociate into its H plus ion and its acetate anion. And so you're not going to get the same level of strength here of electrolyte, but it would be considered a weak electrolyte and have low conductivity. So I mentioned the term a second ago, the idea of dissociation. So what happens here when we talk about solutes dissolving in solution is this attraction of the water molecules to the different ions that are produced. So you can kind of see what's happening here is the positive end of the partially positive end of the water molecule, where the hydrogen is located, is going to be attracted to and surround the chloride ions and pull them apart, whereas the negative region of the water molecule over here by the oxygen, where the lone pairs are sitting, are going to be attracted to the positive, the potassium cation, and pull it apart. So you can see when we talk about kind of this disassociation, this is what's happening as these water molecules are separating the cations and anions based on that attractive electrostatic force. So that's all for the first video here on electrolytes. Your practice will be identifying solubility, what types of things are soluble, what types of solutes are soluble in what type of solvents, and also identifying whether or not something would be a strong, weak, or non-electrolyte.